Hello and welcome to today's course of AI in telecom industries. My name is Dr. Kishore Biswas, and I work as IT training director in Huawei technology companies. First of all, I want to thank you all for attending today's course from a long distance, and I also want to thank TRA for arranging today's course. All right, so let's get started. Today, basically, we'll talk about two different parts. We'll talk about what AI is, and we'll clear up some buzzwords, hopefully. And then we'll talk about how can we use AI technologies for different areas in telecom industries, for mobile carriers. All right. So at the end, we'll have a question and answer session for 15 minutes. At that time, you can raise your questions. It's a pity that I cannot see you, but hope someday we'll be able to deliver such training face to face. So our goal to understand essential concepts about AI, architecture, and development trend of artificial intelligence. That's a big topic these days. And we'll talk about essential concepts of machine learning, the core of artificial intelligence. Okay, and we'll talk about the uses and the use cases of AI in telecom industries. So that's our goal, and that we hope that somehow we can accomplish that in 45 minutes. All right, so before we start, let's ask ourselves a question. The question is, according to your understanding, which picture here do you think represents AI? Okay, we have 5 pictures. As you can see, number 1 represents the robot, right? Our science fiction's movies robot. And then number 2, data center, or you can see a large server, right? And number 3 is intelligent applications that we use every day. Number 4, neural network. Number 5 are good old if else. Now, which one would you pick and why? Well, I'm guessing that you might be picking up different answers. Could be 3, could be 1, 2, 4, or 5. But let me tell you, there is no correct answers. I mean, there is not only one correct answer there. It could be anything, right? It could be the first, second, third, fourth, or fifth. Why so? The reason for that is the definition, the very definition of artificial intelligence depends on the era we're talking about, right? So the term artificial intelligence was coined in the year 1956 in a seminar by John McCarthy, okay? So at that time, scientists wanted to give machines, the computers, the capability of showing human-like behavior, okay? So at that point, if machines, in other words, the computer software could make any decisions, if else kind of decisions, that could be thought as some sort of AI behavior, artificially intelligence behavior, okay? So let's have a look. If we separate this development era of artificial intelligence, we can divide this development era into 3 different segments, 3 different portions. The first one, we call it weak AI. The next one is strong AI, and then super AI. Now, what are these? We have some key measurements for that. In weak AI era, we simulated the human reasoning processes. For example, if the machines could make decisions based on if-else situations and conditions. Then we developed expert systems, and that is very mature. We do have many different types of expert systems. Now you might wonder what expert systems are. IBM's Watson is a good example. And there are many different expert systems in the world these days. Expert systems are the systems which are, very experienced, right? So well-trained machines that can perform specific tasks in that field. For example, in medical department or medical science, there are many expert systems, big systems that has all the information and the data necessary to perform any tasks, right? You can think that as a machine doctor. What makes a doctor different than our other friends? What makes a surgeon different than our other colleagues and friends? The sergeant or the doctor is a special person, is a specialist who has the necessary knowledge in that domain, right? In medicine or maybe in surgery, that's what they have, the knowledge, they have the experience, and they can provide solutions to their patients based on their experience and the knowledge on the field, right? So if we can make those knowledge and experience available in a software system or machine, we can call that an expert system, isn't it? So the expert system is just expert in its own domain, not in other domains. So anyway, in this weak AI era, we have different types of expert systems. The next criteria you see here, which is important, especially important for today's AI development, which is called learning process, right? So we hope that our machines, we hope that our computers can learn all by themselves. And later on, when we talk about machine learning, we'll see how that is implemented. Okay, so for now, let's take it for granted that this era, today's era of AI is mostly learning oriented, okay, learning based. And then if you move forward to the next era of AI development, which we call strong AI, and what do we think that what are the capabilities that we expect to have in this era? Reaching human mind, understanding complex concepts, self-learning, all right? So let's talk about the first one, human mind. Human mind is highly complex system. It's a biochemical system that we all have in our brain, in our head, right? So far, no machines were able to surpass or even get close to this system that we have throughout our birth. But that is something we hope to occur through our AI development. Understanding complex concepts, right? What does that mean? For example, understanding human language, understanding natural language. Today, even though we have different types of machine translation softwares, right? Google Translation, Python Translation, or any enterprises customized machine translation platforms. We know that the machines can translate one language into another one without understanding the context of the language itself, right? So how does it do that? It does that by different types of statistical analysis. It doesn't have to understand the semantics or the ambiguity or the inner meaning of the language. Okay, so it just translates that based on the surface data it has. Now we hope someday our machines, our software can understand the context of language, right? So the intonation, the emotion inside the language. We know if I say something, it's just a word, okay, and okay. These two okays mean different things, don't they? Based on the intonation and the pronunciation we have. But machines so far are not able to understand complex language understanding. So that's the thing we want to accomplish in the next era of our AI development, right? Which we call the strong AI era. Then self-learning, that is also another key ability that we want our machines to gain. That means that right now we are teaching our machines, and our machines are learning throughout the mechanism of machine learning and deep learning. But the process has already started with a name called AutoML. So in the next era of AI development, we want to see our machines learn all by themselves, given they have lots of data. So far we've talked about weak AI era and strong AI era. Right now, we are standing in the junction of these two AI eras. We have accomplished expert systems. We're doing a lot of things in machine learning and deep learning area. Okay, so as you can see from the slide here, we're standing here right now and moving forward to the era where you can reach these goals. Now, in the previous slides picture, you might recall there was a picture of robot. Always see that robot from science fiction movie, Terminator 2, right? Hasta la vista. So that thing, that human-like machines are not possible till today. And those might appear in the far future, which we call super AI era. In the super AI era, we expect our machines to go beyond human mind. They can do more than human mind is capable of doing today. And then having creativity, right? So that would be a big distinguishing between machines and human. We can see machines also can be creative. We don't know if we will see those days coming in our lifetime, but that's what we can expect. So anyway, the takeaway from here, there are different eras of AI development, and it depends which era we are in and how we call AI. So since we already accomplished these learning processes, now we can expect few capabilities from our machines to be called as AI. So what are those expectations? So we expect our machines being able to do recognition, do prediction, and then learning. So if our machines, if our systems can have or exhibit one of these or all capabilities, we can call them AI applications, okay? Remember, please, recognition, prediction, learning. There are many more, but let's just say these three are the key to be called as AI applications. Right, so what is AI anyway? If you ask an academic and if you ask an AI application developer, you might get different answers, right? But as you can see from our AI tree picture here at the left, the whole area, whole discipline is actually a blended discipline. As you can see, the root of AI tree is, it's diverse. It's a mixture of many different disciplines. For example, mathematics, computer science, ranging from robotics to biology, then logics to philosophy. All right, so AI actually takes different theorem and knowledge principles from many different disciplines, put them together, and provide us with the means of different applications, which we have as the upper portion of the AI tree, branches and leaves, all right? So these are applications. So you can call AI or artificial intelligence as a box of tools, a box of applications, all right? And as you can see, machine learning is at the center, at the core of these different applications. There are also natural language processing, voice recognition, different types of recognition, neural networks, and intelligent agents, computer vision, and so many things. So in short, in academia, we call AI is a mixture discipline, but in the enterprises, we call its application, right? Different types of application. AI is a box of tools. AI is a box of applications or services. Okay, so here we'll have a look at how the core of artificial intelligence actually work. Just a comparison between machine learning and human learning. Right, so we know as human, we are born with this capability of learning. Since the time we're born, we took our first breath. And we know that when you're born, we took the first inhale, right? And when we die, we go away with last exhale. So in between the first inhale and the last exhale, we don't stop learning. We're always learning in some sort of ways. And we learn through our 5 sensory organs. We know that eyes, ears, nose, skin, tongue, right? So we have sensory organs. We have bionic sensors. And throughout those sensors, we gather different types of experiences. We gather physical experiences, intellectual experiences, emotional, social, spiritual, very different types of experiences. Now, we can do an analogy of those experiences as data, right? So those experience or those data is kept or saved in our brain in different neuron cells, isn't it? Then we process those data, process those experience. After processing those data, sorry, excuse me, and the experiences, we come up with some understanding, some sort of understanding. We learn a lesson, or we have some sort of model in our brain. Okay, and based on those understanding, we take actions. And after we take actions, we can learn back. So from the action, we can get feedback, think about it, process this data, and even rectify our lesson. We have a better understanding on our physical world outside us, isn't it? Surround us. Now, how do machines learn? Machines don't have that leverage and the capability of having bionic sensors. They don't have a chance to go to school, right, like us. So the basis of experience for machine is to have data, huge amount of data, which we call big data. Okay, so we provide machines huge amount of data, and they perform calculations, analysis based on different machine learning algorithm or deep learning algorithm, which is machine learning processes. Throughout that process, throughout that analysis of big data, machines do have some understanding on the fact. They do learn some lesson. In other words, they create or train some model, machine learning model. Based on those models, then AI applications or services take actions, given an input, and they come up with an output. All right, so that's the analogy between human learning and machine learning. Hopefully everybody got that. Didn't you? If it's not clear yet, don't worry. We do have a slide after that with example to make that clear. So usually you understand a question towards you, a question to think something about. We know the more we get old, the older we are, the wiser we might expect to be, right? So more experience, more wisdom. What do you think? Is it also true for machines? If we feed more data to the machine, would we expect better performance from them? Please think about it. Right, now we're talking about this machine learning, then feeding a huge amount of data and which you call big data. What is the relationship between big data and artificial intelligence, or at its core, machine learning is? Let's have a look. So here from this slide, we see you have 5 different rectangles labeling data, information, knowledge, insight, and wisdom. Right, our goal is to take raw data and reach as far as we can. At the leftmost, we see that these circles, right, represents raw data. It has no processed portion. So throughout different types of analysis and modification processing, let's say classification, from data we have information, which is classified. Now, throughout information, throughout association, we can reach to something called knowledge. And then mining knowledge, throughout mining knowledge, we gain insight into some facts. And then wisdom, right? Wisdom is something still human. No machines have ever shown this behavior of having wisdom. We wish they could. So our goal is to reach from data to insight. So we provide huge amount of data to our algorithms, and then it can come up with valuable insight to the relevant fact. That's what I want. That's what is big data mining is all about. Now here, from the right-hand side picture, from the Venn diagram, you see the artificial intelligence, if you think that a circle, and you see there's a core, which is represented as blue, is machine learning. And then we have deep learning. Deep learning is a subset of machine learning, right? Now, big data is related to that in this way, that big data is being fed into different types of machine learning and deep learning algorithm to do analysis. Now, if you think artificial intelligence, AI, as a vehicle, a car, then you can think big data as its fuel or its energy source. So we need data, we need big data to fuel our AI engine, all right? Would you remember that? I guess that's easy to picture, isn't it? All right. Now, once again, so we saw that how we want to go from data to our insight. But if I ask this simple question, what data is? What is data? How do you define it? You might come up with an answer called data is information, data is text, data is audio, video, all sorts of data that we gather around us. Right, that's all true. But if I put it this way, data is the abstract representation of our real life phenomenon. Abstract representation. Would you agree? See, right now you're viewing me, you're streaming, you're viewing this streaming, you see me, you see my background, you see this PowerPoint, right? So it's virtual, isn't it? So you see me, you see this picture, you see this situation. Throughout this data transformation, this whole picture is taken by a camera in form of data, in form of color and pixels, which is transformed and transmitted through internet, and it's represented in front of you with your screen, isn't it? So see, whole me could represent it as data as well. So almost everything on Earth could be represented as data, and that is promising. All right. Right. So what do you think? Is it possible to express almost everything on Earth using data? Please think about it. Right. So we talked about what AI is, right? Its definition, and we'll see some AI applications. And I believe you have already seen them. You are using them already. Okay. So, but again, let me list them out. First of all, as we see, face recognition everywhere. You go to the airport now, you go through the immigration, you can see face recognition. In some secured areas, you also pass through the gate just by the face recognition. All you have to do, you have to look at the camera, and then you can pass if you're authorized one. All right, then virtual games, interesting one. Is there anybody who had this opportunity to play virtual games at home? There could be. Then VR, virtual reality, AR, augmented reality applications. Okay, then voice to text, a very old one already. Machine pets, smart promotion, recommendation engines, medical image recognition systems, weather forecasting, and space exploration, right? So we can use, these are somehow matured technologies, matured AI applications that we see or understand or use almost every day, don't we? Here, I'll talk about these two different applications in red, right? Virtual games and machine pets. Why are they AI applications? Remember, we said that in this era, the end of weak AI era, we expect our machines to learn. We expect them to have three different types of capabilities. What are those? Recognition, prediction, and learning. It can recognize, right? Image, voice, audio, video. Learning and prediction. Learning means it can learn from data. Remember how we mentioned machine learning and human learning, how we did the analogy? Right, so here we can expect these applications can learn. Now, what it means to say learn? To learn, it means the performance gets better over time as we have more things to learn, as we have more data to do analysis, right? So virtual gaming is a gaming kind of thing. All you have to have a big screen with a camera or different cameras attached to it. And at the end, there would be, of course, AI algorithms, AI applications. What happens throughout this game, let's say this is volleyball game, or it could be an any game. Now, all we have to do is to stand in front of the screen, stand in front of the camera, and try to mimic the way we play without any real ball. Let's say that's a beach volley. We don't have to go to a beach in this pandemic time. All we have to do to set up the screen in our home and just trying to play, right? So what happens, as you can see from this picture, players are mimicking, meaning that they're virtually playing the game. The body gesture, your movement, would be captured by the camera attached to the screen and being analyzed. So the algorithm behind it can recognize throughout your video which gesture are you trying to pose there. So it can say you're smashing a ball or receiving a ball. Based on what you're doing here, AI algorithm will understand your gesture and will take actions based on your behavior, your gesture, your move of the game. You can see the player in the computer, they're also playing, and you can see the result. So that's one thing. It can recognize our gesture. On the other hand, it can learn. It can get better over time. That means at the first time we play with the computer in this virtual gaming environment, we might win, right? But more we play, it gets harder to win the computer. Why so? Because the more we play, computer has more data to do analysis and to get to insight of how we behave, in which area we do have strength, right? So maybe I have a strength in smashing volleyball, or maybe I have a strength in receiving volleyball, or I have strength or weaknesses in some parts. So the more we play, the more we expose our behavior, more we expose our habits and strength and weaknesses to the computer, right? So it can analyze and can learn. It can train a model. Based on that, can play against us, and it gets harder for us to win the computer. So once again, these virtual games have the ability to recognize and learn, and at some point even predict. That's why I can call these virtual games as an AI application. All right. So it's true for machine pets. I'm going to go into details with that, but it can also recognize, learn, and maybe predict. All right. Now it's a question for you. Now, I don't know if you have played this game called Super Mario. It's kind of an old game from 80s, I'd say. And in this game, what you have to do is just use your joystick, mouse, or keyboard. Then you have to move forward. You have to go through different stages, and you have to complete that. You have to gain some coins. You might be penalized or eaten by, animals, things like this. So you move fast, you take decisions, right? And based on that, you can go through different stages, and then you can win. That is a game, Super Mario, okay, which is very popular in China, was very popular in China. And then we have this application called Google Search Engine. Now, my question to you, which one of these two applications is AI? Or you think both are AI? Why? Okay, think about it. Right, so since I don't see you, I'm assuming that you made the right answers. So the answer here is Super Mario is not. Okay, so I'm gonna leave that question for our later section. Okay, so think about it. I'm gonna give the answer right now. Okay, so here I have a quick quiz for you, which is, which stage of AI development are we presently in? What do you think? Are we in weak AI era, at the end of weak AI era, strong AI, super AI? What do you think? So give your answer, and maybe we can get to know about that later on. Okay, one other thing to mention here is that you might hear these two terms called robots and bots. The differences between robots and bots are such. Robots usually have mechanical hands or mechanical devices attached to it, whereas bots don't have any mechanical devices. These are basically software. So you can chat with it and you don't even know that's human or machine, right? Code bots that can help you write different computer codes. Spiders that can help us crawl different web resources. And you can see Android cyborgs or industrial robots, they're with different physical devices. That is the difference. All right, here I'd like to mention these different areas of artificial intelligence. Artificial intelligence is a huge topic, right? And now there are many subsectors or subfields of that. From the picture at the left, as you can see, you can think of artificial intelligence having different sectors of machine learning, planning, robotics, computer vision, speech recognition, expert systems, natural language processing, and so many things. Okay. Then again, machine learning is also divided in different parts, but deep learning is one of them. And as you can see from the left picture, these are very popular and well-known subsectors of AI. Beside these subsectors, we do have other subsectors, but we'll not talk about this in this class. So that's to give you an overview of the subsector and how it's organized. On the right-hand side, as you can see, the classification of machine learning, right? Machine learning is the core of AI. Machine learning is the part that enables AI to learn and make distinguishing between our old-aged AI, ethos AI, and today's learning-based AI. Now, it might be a little overwhelming for very new beginners, but let's say machine learning itself is also divided into main three parts, main three stages, or you can say main three classes. One of them is called supervised learning. The other one is called unsupervised learning. And comparatively newer one is called reinforcement learning, right? Supervised learning, unsupervised learning, reinforcement learning. We do have courses in details for each one of these, and where we learn about them, we learn about different algorithms, and we do hands-on practices, and we create small AI applications, right? So if we have chances to be in those courses, then we might talk in details. For now, it's just to let you know that these are the subsectors and the subparts of machine learning and AI. So the takeaway is that machine learning, AI is not only about machine learning and deep learning. There are other different sectors that people learn and get expert in. Okay, so that's the subsectors. And a little bit of history, as you can see from a right, these four geniuses and famous personals are considered to be the founding father of artificial intelligence, right? At the first right, you can see Alan Turing. You might have heard his name many times, was the pioneer in artificial intelligence. Then the mostly known person is called John McCarthy, who came up with this name of AI, artificial intelligence, in a workshop in Dartmouth. And with this seminar, they came up with some expectation of AI. Then also in parallel, John von Neumann was also a pioneer in AI researches. And you can see Claude Shannon, we know that he is the founding father of telecommunication, right? Throughout his information theory, right? So that's a little bit of the background and the history. Now let's clear up some misunderstanding about AI, which is very easy and you can grasp that knowledge in just seconds. First of all, I'd like to ask you questions and get to know your answers, but since it's just a one-way broadcast and I don't have any way to direct right away, so I'm just going to give you the right answers. So these are all misunderstanding, okay? These are all wrong. That is to say, AI is not equal to robot by any means, all right? AI is far away from ordinary people. Not true. These are all wrong statements, all right? So why so? See, we're already using AI applications these days through face recognition towards different gaming, right? Text to voice, different machine translation, and different types of search engines. So AI is there already. We're using this. Universal AI will come in the short term. By universal AI, we mean super AI. And by now we know that is not true. Okay, so super AI or universal AI is far away still till today. Now, AI is an independent technique, or it is not. It's not an independent technique because we know that it is rooted in mixture discipline, right? So it is not independent. And then the next statement, which is again wrong, artificial intelligence is conscious. No, it is not, right? It doesn't have a consciousness, as you know. Then artificial intelligence would replace human work in the short term. That's a big debate, but it's still, again, it's wrong statement. As other revolutions, right, industrial revolutions or information revolutions, yeah, there might be some manual jobs that could be replaced by machines, but again, it will bring even more opportunities where human will be required to do their jobs. Okay, so that's not a huge negative concerns, in my opinion. All right, how fast time flies. All right, okay. So here I'm gonna touch the scratch a little bit for this moment, right? So a perceptron, as you can see, that's a single smallest unit of neural network. Now, what is a neural network? Neural network is a way in deep learning to mimic human brain. Sorry, let me go back. To mimic human brain cells and how they compute. And throughout these different layers and the activation function, we come up with some results. We give input and we get output, but those output could be wrong at first. Then we give feedback and the neural network gets that feedback through back propagation and corrects the parameters and through the activation function. So in short, neural network is the deep learning. The name of the deep learning is deep neural network. So the learning that happens throughout the deep neural network is called deep learning. It is a very long topic to talk about, which we do have courses on. So just here, what I wanted to do in this a few minutes, that this perceptron and the neural network is a different sector, different ways of learning for machines, okay? So here we always see when you learn about neural network, this common example of how neural network could recognize handwriting digits, okay? So hopefully we'll have chances to talk more about it in details. Right here, let me go through the structure of artificial intelligence a little bit. So the left-hand side, we have data architecture, then modeling architecture, and then last, we have the intelligent architecture. Remember, as I said, if we view artificial intelligence as a vehicle, then you can think big data as its fuel. Now, at the end, at the first-hand side, we have the AI infrastructure, we have data infrastructure. So we do data aggregation, data processing, and it requires storages, right? Distributed storages and storing them, processing them. And that's a whole big story, how we process our big data in big data platform, right? Then we feed those data in our machine learning, okay? And then we create or train model. We train modeling, right? Then we give an example of how we can make a model. And based on those models, then we provide different AI services. And in different sectors, for example, in medical treatment, smart appliances, finance, right? Unmanned vehicle, translation, industry, and smart city, we all have different sorts of AI applications in place. Okay, now here's this question for you once again. Which one of the following is an AI application? What do you think? Right? Face recognition, right? Or will you get the answer? Okay. Now, here is this AI architecture. Once again, I'm going to go through briefly. No matter what architecture you're planning in, you do have to have a hardware-based low-level architecture. Then we have this AI model training, and there we'll learn about machine learning, deep learning, and different algorithms, right? And on top of that, we have some open source or customized platform that gives us the ability to utilize different libraries of those machine learning and deep learning functions, right? For example, TensorFlow, Keras, Torch, Caffe, Theano. These are deep learning platforms, machine learning platforms. All right. And on top of that, you can use those platforms and provide different types of functionalities or services, right? And again, as I mentioned, that this whole AI AI core is machine learning and deep learning, and they are segmented in supervised learning, unsupervised learning, and reinforcement learning. Briefly, in supervised learning, we have data and we know what they are. So we have input and output. As input, we have data. As output, we have label, what they are. And in unsupervised learning, we have data, but we don't know what they are. And reinforced learning is an action-based learning. So our software or that machine, they take actions. And based on that, we give feedback. We give reward or punishment kind of thing. And that is reinforcement learning in short. Okay, so we're gonna end almost, we're at the end of this today's course, right? It's been almost 40 minutes, and I wonder how fast time flies. At the end, let me give you an example of machine learning, and hopefully that will help you understand this. Now let's have a look. Here we have an example of input output, right? So 0, the corresponding one is 32, and then 8, 46.4, 15, 59. What do you think the answer is to 38? So what is the corresponding answer to 38? Please think about it. Well, I know you might be, you are all smart enough to guess this, or maybe it doesn't matter if you don't guess it at this point. But the way you're thinking to get this answer is the way of machine learning already. Because you see what happens, you're given the input and output. So what you're trying to do is to guess the inner meaning or the pattern of this number set to get the answer, right? So you are given input and output and you're trying to get the answer from it. That is the way machine learning works. By the way, the answer is this, right? 100.4, and that's a Celsius to Fahrenheit transformation. That's not important. So the point is, the way to find out the pattern from input-output pair is the way of machine learning does. Now, another example. Let's say somehow you have to write a piece of software that can give us the result in a beauty test. So we give many different types of pictures, and your software will have to say if it's beautiful or not. How do you do so? Even though we can put up many criterias, for example, height, width, weight, face shape, eye diameter, nasal length, etc., etc. It is very trivial to write a program that can come up with this decision of making, this result. So what could be done? What we could do, we can have data set, right? So for example, we have many different pictures like this in our database, and we label them in this picture. Like I said, maybe someone is beautiful, someone is average, and that's our data set, right? So we have data, we have our label as output. So what you do, we feed them in some neural network or any kind of machine learning algorithm, and our algorithm learns from the data. It says, what is it that makes this photo beautiful, whereas the other one not? Okay, so it learns something. It learns a lesson, and that is called a model. In fact, that is a function, right? So throughout analyzing this data, it comes up with a model. And based on that model, it gets the new data and performs its output. So maybe we input this picture in there, and then it gets, this picture is extremely beautiful. The probability of this picture, Mr. Bean being beautiful, is 99.99%. How do you think about that? And that's in short what machine learning is, right? Right, so again, time is almost up. In traditional algorithm, what we have in traditional programming, we have an algorithm written to it, and we input something. Based on that algorithm, we get output. But in machine learning approach to do programming, we don't know the algorithm. We don't know the rule here. We give input and output, and then we try to learn what the algorithm is, all right? And again, it goes through this different process, right? So we put data, we split the data in many different sets, calling training set, test sets, going through the model, and then we do prediction, and we go through the evaluation. It has detailed steps. Hopefully someday we'll be able to do all this training in details, right? So that's in short how machine learning works. All right, so at the end, I'd like to cover that. What is AI? AI is a box of tools. AI is applications, right? AI plus something is meaningful. That means AI is a technology, right? AI is a box of tools. If we put them with something in real life scenario, let's say AI plus car, that becomes unmanned car. Then AI plus appliances, that becomes smart appliances. AI plus retail, that becomes smart marketing, right? AI plus city, that gives you smart cities, doesn't it? Right, so at the end, I'm gonna finish that with one use case of AI in telecom industries, right? In telecom booth, or you can say service places, this AI application is implemented, where throughout the image recognition, we can find out our customers' situation. For example, in our service booth, the customer comes in, he might be in hurry, or he or she might be an elderly person or a person with a baby. So based on that, we can analyze their gestures and their movement and can guess what situation they might be in. So if they're in hurry, if they're with a baby, they might need some special care. And based on that criteria, we can provide them with different suitable services. Right, so anyway, due to the time limitations, I have to stop it here, and I have to give you the chance to ask questions. Hopefully, this brief, short, but somehow useful course was not in vain at all. So at the last hour, I'm going to give you some times, right? You can ask questions, and okay, I've already get the question. Is the super AI not available due to lack of processing speed or the lack of big data? Very good question, right? Remember the definition of super AI capability, then we expect our machines to be creative or exceed human mind. Right, you're right. You said that because lack of processing speed on big data, that's partially true. But again, it's the way we compute. Right now, our computation is basically in serial manner, but we'll have to move towards parallel computing and in huge capacity. Quantum computing could be a solution to that problem. So there are many different computing problems which are not solvable in a given period of time with the present technology. So maybe quantum computing plus a new big data technology would be the way to move forward. But even big data might not be the answer here. Why so? So when human process data or human thinks or recognize things, they don't have to think data-wise. Example, if you look at your friend, then you don't have to go and scan through his face, right? Like these pixels. You just look at him and you know that's your friend, right? Our brain is so good to do this kind of parallel processing, and it does not work in data level. It works on reasoning level, right? Reasoning. So from data processing, we'll have to move towards something called reasoning processing, right? We don't have to go through scan all the pixels, but maybe just by looking at it, our machines will be able to reason it to be come to a conclusion. So quantum computing plus reasoning processing instead of processing big data might be a way to overpass human mind or being creative. And still, being creative could be very tricky. All right. Okay, the question number 2. What are the top countries working on super AI provision today? All right, so far I know that United Arab Emirates is also one of those, because you know that you have a ministry called AI ministry, right? So UAE is prioritizing its AI researches, as well as Western countries, United States, even China, Korea, Japan. They're all giving AI is a high priority and doing research and coming up with cutting edge technologies. Right, so far I got 2 questions. Right, so let me continue the first question. Why I meant by saying being creative is very crucial. See, humans are creative. What do you mean by creative? You come up with something new, something unique. To be creative, we need to have spiritual influences, right? So where does this spiritual influences come from? It comes from the fact that humans are mortal, so we die, and that's a huge motivator for human life. But would machine ever die? If they don't die, if they don't have any death, how can they can gain that supernatural, I mean, like spiritual influences, right? So that's something to think about. Meanwhile, in short, I have a question. So in short, do machines have obtained relevant data by themselves in order to achieve more advanced AI technology, otherwise moving away from big data? In short, do machines have to obtain relevant data? Yes, exactly. Exactly. Very good understanding. Right now, human or engineers have to gather the data, process the data, even go through the feature engineering to feed those very relevant, useful data to machine so that we can get some useful result out of this. But if you want to move forward, yes, we expect in our next stage, machines will have to gather the data, find it, verify it, process it, and then learn from that. Yes, you're right. That was question 3. Machines have to obtain relevant data by themselves, analyze it, and finding the reasoning inside the data. Right? Am I talking too fast? Right. Any other questions? What AI applications would you like to see in near future? I would like one. Let's say we have to go through schooling for a long time, right? I went to schools, different types of schools, like primary, higher secondary, then colleges, all through my life. I spent 30 years in schooling to learn something, right? So what if we came up with some sort of augmented organs, or you can say biochips? All you have to do for a baby when it is born, then you have to implement that chip in its brain, his or her brain, right? Some sort of attachment, so that they have the basic knowledge, basic data of at least higher secondary level schooling. So they don't have to learn through that 14 years, right? 12 years. So maybe when they're trying to cry, they can spit out some formulas of physics or chemistry. How cool that would be. Or at least I'd like some applications that can boost up our memories. Right, question number 4. What about bias of AI, which is currently happening? How Huawei dealing with topic? Bias, right. Right, the decision that is coming out of different modeling, it's not perfect, right? So as I mentioned, something called feature engineering, right? Feature engineering. So we feed different types of data, right? We feed relevant data and we think data is clean, relevant, but still it's not at the first go that we get the right answers. Engineers do have to go through this trial and error, right? Tweaking, testing, and tuning the parameters. So the key here still today is the feature engineering, right? The topic of feature engineering. By feature engineering, we mean uh, the fields that we choose. For example, we want to get insight of, let's say, work hiring or employee hiring scenario. So what are the important most criterias of an applicant? Say there are many criterias: name, addresses, right? Then his or her academic degree, work experience, age, right? Practical project experience, and other skills. Now, these are all good criteria or features we call that we can feed to our algorithm to find out the best suitable most applicant for this job. Now, we might find that different features fit to the machine can give different outcomes. So we have to choose the most relevant features, right? So we think maybe instead of feeding the location information, we better feed academic degree, right? Then the work experience, the real life project experience, things like this. But again, when we have huge data, right? It might come up with thousands of features, even in some cases, millions of features. Now, from those huge amount of features, how do you select the right one? How do you find the right mixture of those features? So far, engineers have to do that. And in Huawei, we try to do feature engineering through our experienced as a business experts and field experts. And that's how we try to solve this bias problem. Okay, so by now we have a question. Why are AI devices so expensive? How do we dispose of unnecessary? So why is it expensive, right? So AI is not only software-based solution, it is also hardware-based solution. As we know, for AI applications, we do have to process huge amount of data, right? And then we have to get to the insight from the raw data to the insight as soon as possible. So that requires huge amount of calculation, computing time. So for that, in hardware level, we also have to implement which is suitable for AI computation, right? So we do have AI chips, then we do have GPUs on top of CPUs. So these are specially made hardware that can handle billions, if not trillions, of matrix calculation, which are at the core of different machine learning and neural network processing, isn't it? So those are very sophisticated hardware, but hopefully someday it will be cheaper, it'll get more cheap. I guess you can buy mobile phones, which has AI capabilities already built in, so which are not that costly if you think about it. But yes, the more we go forward, the cheaper it becomes. All right. With okay, getting more questions. With how far are we in technology today? It is possible for machines to wisdom, right? As I mentioned, being in the super AI era and machines to get wisdom, it depends, right? It depends. As I mentioned, yes, as we can move from data processing to reasoning, and if we can implement our quantum computing in a certain level, then we might get to the point where machines can gather their data and learn by themselves. But still, it will be a question if ever will they be gaining wisdom like human, right? That's still a question which we don't know about for sure, right? Okay, I guess, okay, I have a few more minutes. Let me get to other question. With how far are we technology? How many people are usually involved in training data featuring engineering? Right. Okay, so yes. So for data, so feature engineering, as you mentioned in our platform, it could be from tens of different engineers to hundreds of different engineers, depending on how big the problem is. So who we include in this process? We include industry expert, right? Field experts. They may not be experts in machine learning, but they understand the business, they understand the operations, right? So we have a mixture of different talents as a feature engineering team. So there are people who are good at machine learning, deep learning, the engineers, right? They're data scientists. Then we have the field experts, right? Business experts, and a mixture of that. So they decide which features of the given data are more important than others, and they have to go through a trial and error, and they have to apply this knowledge based on their experience, right? So that's how many. It depends. Could be tens of them, and for small problems, few engineers would be okay. For bigger problems, could be hundreds, right? Okay, so I think that's about it today, right? It's been a very fast lightning 1 hour, and I had to speak very fast. Hopefully, most of the information covered today was somehow useful to you. And let me tell you that it's not end, it's the beginning, right? It's just the beginning of a new era. If you are interested in this field, which you are, I guess, then take that as a starting point. Our future is ahead, and AI is seemingly leading to that path. So no matter what, we get to know the technology. Maybe we'll be expert someday, or maybe at least we'll be expert in using this technology. So once again, my last word, I'd like to finish by one sentence, is that people think that AI might be a threat to us, but I'm optimistic, and I would say it would never be AI versus human, but it would always be AI plus problems. Sorry, it would be always AI plus human versus our problem. So together with our AI capabilities, we'll be able to solve our problems better way, so that we'd have more time to do what we do best, being human. All right. So in this time, stay safe and be productive. Hopefully I'll see you next time. Thank you all.